Alright, good morning everyone. Good afternoon, depending on when you're watching this. It's Ugodi right here from Ugodi Solution, and in today's class we're going to be talking about how to draw the skeletal structure of organic compounds. So without much ado, let us get right into it. So before we get right into it, you need to understand the importance of learning this. One, it makes the whole task of representing organic compounds much easier. And secondly, more often than not, examiners expect you to represent organic compounds in that way. So it's only safe to learn how to actually do that. So because this is a marathon class, I'm gonna make everything as snappy as possible. There are 4 basic rules we need to take into recognition when drawing the skeletal structure of organic compounds. The first one says represent each carbon as the vertex of a line. To start with, the vertex of a line is just where a new line segment begins. Say for instance, if you have something like this, we have 1, 2, 3, 4 verticals. By the way, vertical is the plural form of vertex. Alright, so each of these represents a carbon atom, right? The second rule says omit hydrogen attached to carbon. So, ordinarily speaking, if there was a carbon here, for instance, say a secondary carbon atom. By the way, a secondary carbon atom is that which is attached to 2 other carbon atoms, right? Say a secondary carbon atom, and ordinarily, to complete the tetravalency of carbon, we are meant to add 2 hydrogen, right? Now, all of that hassle won't be there when you're dealing with the skeletal form, because you won't have to come and say hydrogen here, or hydrogen here, and hydrogen here. Alright, so you can see that it actually makes our work a lot faster. Take for instance, this structure I just drew now, the structure I just drew now is simply butane. This is butane, but it would have taken us almost a minute plus to actually fully draw it. Now in this form, I've not even added the hydrogens. Imagine if I had to add all the hydrogens. But to make everything simple, this is what it is, and by the end of this class you should be able to draw the skeletal structures of compounds. Alright, let's continue by considering the rule number 3. The rule number 3 says use lines, alright, to represent bonds. So still using the butane, right? Each of these lines represents the bonds, right? While the verticals represent the carbon atoms. So okay, so this represents this bond here represents this bond here represents this. Okay, you get it now, right? So the rule number 4 says show all heteroatoms. Heteroatoms are just basically those atoms that are neither carbon and hydrogen. Alright, so any other atom at all that is not that is not carbon, that is not hydrogen, you're actually going to show them. Alright, so let's say we want to draw the skeletal form of, let's say, ethanol. Ethanol is a member of the alkynyl family, by the way, and they have a general formula CnH2n plus 1 OH, right? CnH2n plus 1 OH, and ethanol has the formula C2H5 OH, right? And you want to represent this, okay? Now, what that rule is trying to say is that after you have indicated your carbon here for these 2 carbons and omitted these 5 hydrogens, because basically we said we are going to omit the hydrogens that are attached to carbon. Only those that are attached to carbon you're meant to actually omit. What that rule simply says is that now that you want to attach this, alright, this is an heteroatom, you are going to represent it. So this is simply ethanol. right? This is simply ethanol. And you would agree with me that this skeletal form is much easier than trying to draw the normal Can you see that now? See how long it took us to draw it. Now you get to appreciate this skeletal form when we begin to deal with even larger and bigger organic compounds. Alright, so we're going to do a couple of examples to actually show those rules being used in practical exercises. So I will be taking the first question from the past question booklet because this is a marathon class and it's only imperative that I do that so that we're killing two birds with one stone. Right? So that's if it's possible, So it said draw the molecular structure of the compound 4, right? Ethyl 2 methyl heptene. Now, in an exam scenario, you know what? You're always conscious of time, and whatever is going to help you save time is actually beneficial to you. Ordinarily, drawing this, because you see hept here, just simply tells you that there's going to be 7 carbon-carbon bonds. And if you want to ordinarily draw this, it's going to be something like this. 1, 2, 3, 4, 5, 6, 7, being our longest chain. And because it is heptene, right, single carbon-carbon bond. That is why we have the single carbon-carbon bond, right? Then you can see ethyl, 4 ethyl. Let's assume we're counting from here. You can actually count from there too. So that's 1, 2, 3, 4, 5, 6, 7. Right? You come here, you attach an ethyl group. Mind you, there are hydrogens here that if you want to draw it this way, you have to indicate. Right? And then 2 methyl. You go to carbon number 2. You might just as well put it on top. This is methyl, CH3. So you now start writing all the hydrogens. Imagine how many hydrogens you're going to end up writing. All of that is waste of time in an exam scenario. So what you will do instead of doing this is to draw the skeletal structure of this compound. And here's how you go about it. You pay attention to rule number 1, which says represent each carbon as the vertex of a line. So you can actually start anywhere. I'm going to give us a couple of varieties, so whatever works for you, you do it. You start from a point and you start counting from that point. A common mistake people make is that they draw something like this and then that's when they count 1. No, this is already 2. But there are already 2 verticals here with this and this. Right, so 1, 2, 3, 4, 5, 6, 7. Okay, you just take a zigzag pattern. Someone else might as well start from like this and say 1, 2, right? 1, 2, 3, 4, 5, 6, 7. Both of them are heptene rather. Alright, single carbon-carbon bond. Right, 7 of it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay? Now of course, when you're naming, the next thing you do is you now place your substituents, right? 4 ethyl. Let's assume we are counting from this side. 1, you can just indicate it with numbers written, in a tiny manner, right? So 4 ethyl, right? You bend it, that's ethyl. And how do I know that's ethyl? There was a carbon here, right? So we're basically just taking ethyl. Ethyl is just 2 carbons, right? Eth, I taught us that meth is 1, eth is 2, right? Prop is 3, but is 4, pent is 5, and the list goes on and on. So the most important thing is that we have two verticals here, and two of them are representing carbon single bond, and that's basically what ethyl is, right? And then 2-methyl, carbon number 2 is here. Once you take it up, there's just one vertex you added. Do you get it now? So this is simply methyl, and that's it. So now you tell me, between these and what we drew earlier, which is easier? This is much more easier. So let's say someone else that decided to draw it this way, and let's assume the person is also counting from this point. 1, 2, 3, 4, 5, 6, 7. Okay, 4-methyl, 1, 2. Someone might ask, is it a must that you must bend it to this side? You can as well decide to do it this way, like just make sure it is not straight, because if you come now and say 1, 2, you're just wasting your time. The lecturer is only going to see one vertex here, and this is methyl and not ethyl. So instead, there has to be a bend. You can decide to bend yours like this. It doesn't matter. What matters is that there are two particles, this and this, attached to this carbon here. Alright, so let's assume we are doing ours like this, and then carbon number 2 is right here. So we just take one out. You don't have to also draw it straight. You can as well decide on your own that you want to do something a bit different and you can decide to just bend it. Regardless, you're still correct. Okay, so this is just basically an example to depict this. And remember, we had to omit all the hydrogens, right? Because that's the rule. And we use the lines already to represent the bonds, and there wasn't any other heteroatoms, so we didn't show them because this is just simply hydrocarbon, strictly hydrocarbon, no single heteroatom. Hope you understand it now. So let's do one more example to show how these rules are applied in drawing the skeletal structure of organic compounds. So the compound we have on the board is 2-methyl cyclopent 1,3-diene. It's also found in that particular here of the past question booklet. 2-methyl cyclopent 1,3-diene, right? So as usual, we're going to start with the parent chain. So you can see cyclopent right here, cyclopent. Okay, so we're going to start with that. Cyclo, first of all, tells us it's a cyclic compound, an unsaturated one rather, because of the diene. Okay, so it's a cyclic, right, unsaturated compound, and pent tells us we're going to have 5 verticals to it, and the only shape that has 5 verticals is a pentagon. So we're just basically going to draw a pentagon here, and here's how you go about it. You take a triangle, then you add what looks like a square. That just makes it a pentagon. It has 5 verticals, right? So the second thing you need to do, of course, is to number it. 1, 2, 3, 4, 5. Someone somewhere might be like, must I draw it this way? No, you mustn't. You must not. Someone else can decide to draw theirs like this. So long as it has 5 verticals, it's still a cyclopent, right? So yeah, that's the most important thing. So this 1,3-diene tells us that there are 2 double bonds, right? Because you know the ene represents double bonds, right? And it is on carbon number 1 and carbon number 3. Remember, the verticals are just carbon atoms. And that reminds me, you can as well count like this. It doesn't matter. Okay, you just have to indicate it with small numbers to make it easier for the examiner to mark it. Alright, without wasting time. So 1, I'm just going to place a double bond here. Always make sure the double bond is inside, right? And we're placing it between 1 and 2 and not 1 and 5 because we actually counted this way. Okay, now for the second one, 3, we're going to place it here. Someone might ask me, why don't we place it here, since there's a carbon here and it's carbon number 3, and you know, but the rule states that you are according this number to the smaller among 2 bonds. Like among the two carbons surrounding it. So if they give it number 3, it means it's between 3 and 4 and not 2 and 3. If it was between 2 and 3, it would have been accorded the number 2. Hope you get it now. So yeah, that's it. So what we have on the board right now is cyclo, because of course it is end to end, pent because there are 5 carbon atoms, 1 3 diene because there are 2 double bonds. Alright, so now let's add the only substituents we have. They said 2 methyl, right? So we just go to carbon number 2, okay, and just draw something out. It means there is a carbon here, right? And that's just basically methyl. We're not going to begin to indicate all the hydrogens now, because you omit hydrogens that are attached to carbon, right? And here we're done. This is 2, because this is carbon number 2, 2 methyl cyclo pent 1 2 3 4 5 1 3 diene. So I hope with this at least you have a general overview of the steps it takes to draw skeletal structures. Alright, so just to reiterate, the rules are once again: represent each carbon as the vertex of a line, to omit the hydrogens that are attached to the carbons, to use lines to represent the various bonds, and to show all the heteroatoms. So until I come your way again, I remain Ugodi from Ugodi Solutions. Do have a wonderful day ahead.